Right, so you can use the definitional way to compute the sum of squares, but it's not very efficient. I mean, you have all those decimals to work with, and you're likely to make computational errors. An easier way to compute the sum of the squared deviations is by using the computational formula. And the formula is the sum of squares is equal to the sum of the x's squared minus the sum of the x's, the quantity squared, divided by n. Right? So in order to do this, you need to figure out the sum of the x's and the sum of the x's squared. Right? You already know that the sum of the x's is 271. You just add up the scores. Right? You also need to know the sum of the x's squared. So to figure out that, you need to square each x. So 68 squared, okay, it says, okay, 61 squared is 3721, 72 squared is 5184, and then 70 squared is 4900. Okay. So if you sum those x's that you've squared, you have the sum of the x's squared, that gives you 18429. Okay. You just plug those numbers into the sum of squares formula. So you have 18,429 minus 271 squared divided by n, the total number of scores, which is 4. And that gives me 68.75. Note that I get exactly the same sum of squares if I use the computational or the definitional formula. Right? This computational formula is quite a bit easier because you have buttons on your calculator for computing the sum of x's and for computing the sum of x's squared.